In our last video, we learned how to design the sign base here using Autodesk Inventor. In this video, we're going to learn how to machine the base using Autodesk HSM. Let's get started. All right, so once we have our part open, the first thing we're going to want to do is to come on up here to the Cam tab, and we're going to start a new setup. So we're going to click on Setup, and now we need to set up our work coordinate system. And so by default, it's kind of standard to use that back left corner. All right, and as you know, we need our positive X to be going to our right if we're facing our part, and our positive Y to go away from us. So let's come on over here and click on Select. Um, Let's select Z and Y axis. Okay, so we're going to click over here on Y, and now we're going to click on this right here. All right, and now our Y is going the wrong way, so we need to flip our Y, and here we're good. Okay, now let's come on up here to our stock, and we're going to go to a fixed size box, and we want that to be 3.2 inches. Okay, centered by 3.2 inches. And our height is Z, and we're going to offset it from our top of by 0.01 inches. Okay, and that should do it. Go ahead and hit OK. With our setup done, we can start our first operation. So most machining operations always begin with a face. So we're going to come on over here and select face. Okay, make sure your coolant is disabled. And for our tool, okay, you should have installed your acrylic award tool library. So click on that, and we're going to select the 3-inch facing mill. Go ahead and hit select. We're going to go with a spindle speed of 5,000. All right, and a feed rate of 40. All the other default values are fine. For our geometry tab, we're just going to click the circle, okay? And then for our heights tab, the default values are fine here. For passes tab, we're going to use a stock offset and a pass extension. We're going to change these values here. So our pass extension is going to be 0.25. Okay, and what that will do is it'll move our tool a little bit out farther past our stock material when it goes to machine it. And we're going to use a stock offset of 0.5, 0.5 inches. Okay, so that'll make sure our block of stock material is completely faced off. All right, and that should do it. Let's go ahead and hit OK. By changing our pass extension to 0.25, notice our tool path goes farther past our part here. So it's covering a little bit more area here. All right, so for our next operation, we're going to do a 2D adaptive. So up here at the top here, select 2D adaptive. Okay, we need to change our tool, but first let's go ahead and disable our coolant. Our tool, okay, is going to be using our acrylic award tool library is going to be a 3/8 flat end mill. And let's go ahead and select that. Our spindle speed, 5,000. Our cutting feed rate is going to be 60. All right. And we're going to do our ramp as 30 and our plunge as 30. Okay, now let's come on over here to our geometry. We're going to just select the outer edge of our part here. For heights, the default values are fine. For passes, we're going to use an optimal load of 0.2, so a little bit bigger step over. And for stock to leave, we're going to leave a little bit of stock along the walls since this is a roughing strategy. We're going to leave 0.01 along the walls and none for axial. So we're going to basically go completely down to the bottom edge of our part here. We're going to leave no stock along the floor or flat areas. Okay, and one thing we're going to do is we're going to check smoothing this time. And what smoothing will do is it'll take basically a bunch of linear tool paths and convert them into circular or arc tool paths. So it'll simplify your G code. All right, let's go ahead and hit OK. And we have basically our tool path removing the material around our circular part here. Now that the material around our part is removed, we want to go ahead now and do an operation that's going to remove the material inside of our part. So we're going to start with a pocket here, but we're going to do a what's called a 3D pocket. So up here at the top, go ahead and select 3D pocket. All right, we're going to use the same tool as last time, our 3/8 end mill. Make sure your coolant is disabled. In case I forgot to mention that, it should be disabled throughout the entire setup here. So coolant should be disabled in every operation. Our spindle speed, we want 5,000. Okay, our feed rate, 60. And our ramp feed rate, we want 30, and our plunge feed rate of 30. All right, and up here at our geometry tab, we're going to select this inner circle right here, and that should do it. For our heights tab, all of our default values are fine. Okay, for our passes tab, now we got to make some changes here. So we're going to do a manual step over of 0.2. All right, and we're going to do, let's see here. Maximum roughing step down of 0.4, okay, not 0.04. So we're going to, every step we go lower and lower into our part, it's going to be 0.4 inches. All right, now for stock to leave, we're going to leave 0.01 along the walls, and we're going to leave 0 along the flat portions of our part here. So no stock on the bottom. All right, and we're going to check smoothing. And then over here now in linking, okay, the only thing we're going to do is we're going to go with a more aggressive ramping angle at 5 degrees. So make sure you put, and it says helix, and we're going with 5 degrees. Everything else should be okay. Let's hit okay. And that should do it. So you're probably thinking here, but Mr. Fuller, what about this area over here? Okay, well remember this blue line represents the center of our tool. So our tool is going to sweep around here. It's going to leave some stock, but that's okay. When we do our finishing pass, we will clean up this wall later. All right. All right, so that about does it for our roughing operations. Now we need to go ahead and start our finishing passes here. So we're going to come on up here to 2D contour. Once again, we're going to use a 3/8 flat end mill. Our coolant is disabled, but with finishing passes, we want to slow down our spindle speed. So we're going to go with 3,000 and a feed rate of 20. All right. For our geometry, we're going to select this outer edge here because remember we left some stock behind. Okay. But we're going to do something a little bit different here. For our bottom height here, the bottom of height, we're going to change this to minus 0.02. Okay, and what that will do is that'll bring our tool down. So when we're cutting around this guy, it'll cut a little bit deeper. So for our next setup, when we go to face this other side, it'll make sure that we have no material left behind. All right, so our bottom height is, make sure you select that to minus 0.02. All right, make sure your finished feed rate just says 20. We'll check stock to leave and we'll hit OK. And if you look, okay, you can see our tool is going to go a little bit deeper, cut a little bit deeper than the actual part. Like I said, that's to ensure when we go to face this side off on our second setup, okay, it'll make sure that all that material is getting removed. Okay. Okay, so let's go ahead and do another 2D contour. Same tools and feed rates. So we're going to come on over here, 3/8 tool. Coolant is disabled, 3,020 for our feed rate. So everything's the same. Our geometry now, we got to remove the material along our vertical walls. So we're going to click there, and we're going to click there, and we're going to just click there. Okay, and now this is important. You'll notice this arrow's inside here. You got to click on the arrow because if you don't, it's going to just, your tool's going to plow through this plastic portion right here. So by clicking on that arrow, now it's going to go around it. Okay. For our heights tab, everything looks good. For our contour, excuse me, for our passes tab, everything looks good. Make sure your finished feed rate says 20. We will check smoothing. Okay, and we'll go ahead and hit OK. With most of our material removed, now we can start machining out this slot for our sign to be placed into. So we're going to come on up here to 2D milling, select slot. We're going to change our tool to, now we're going to use a 1/8 flat end mill. So a little smaller tool. Coolant is disabled. We're going to go with a spindle speed of 5,000. Okay. A cutting feed rate of 30. And we're going to go ahead and use a ramp feed rate of 30 and a plunge feed rate of 30. Okay. Now for our geometry, okay, we got to basically select this guy right here, this little inside, well, basically the bottom of the slot. Okay. And then for our heights tab, once again, we're going to send our tool a little bit deeper than the part. So we're going to go minus 0.02 inches, not much, but just a little bit. And then for our passes tab, we're going to check smoothing. And then for our linking tab here, we're going to use a 3-degree step down, or excuse me, a 3-degree ramping angle. All right, let's go ahead and hit OK. And here is our slot. And if you look at the toolpath here, you'll notice that, well, it only did a half a circle. So we got to do one more toolpath, and that brings us to a 2D milling operation called a bore. All right, so we're going to use the same tool, spindle speed of 5,000. However, since the material's removed, most of it's gone, we're going to give it a little bit faster feed rate of 40. Change all ramp and plunge feed rates to 40 here, because we're going to go down pretty quickly. And then for the geometry, we just need to select like one of these faces here. Okay, and if you notice, it kind of created this little boring toolpath down the middle here. And then for our heights, same thing. We're going to go minus 0.02. So we're going to bore down just a little bit down past the bottom of our part. And then everything else looks good. Let's go ahead and hit OK. All right, so now let's go ahead and simulate it. Click on Setup, Simulate. First thing you want to check out is you hopefully have a total machining time of around 6 minutes. All right, so you're going to check on stock, and you're also going to check on stop on collision. Hopefully you have no red lines down here, and if you do, let me know. Let's go ahead and play it. Okay, we're going to do our facing, and then we're going to come around and do our 2D adaptive, and then we're going to start our 3D pocket here. And then our 2D contour finishing pass, and then our slot, and then our bore, and we're done. Looks good. Our first setup's done. Let's go ahead and start our second setup to remove the remaining material that's on the top of our part here. So we're going to basically start another setup. Okay, but we need to flip our part over, and we're just going to select this back corner. And notice our X and Y aren't correct. So we're going to come on over here to, well, let's see here. Let's go ahead and do a Y and Z. So I'm going to select my Y here as that. And then I'm going to flip my Y. And then I'm going to flip my Z. And I'm good. My positive X is going to my right. My positive Y is going away from me. And positive Z is pointing up. So that's what we want. All right, now for our stock, we're going to do the same thing we did before, but something slightly different. We're going to go with 3.2 again, centered, and then 3.2 for our Y, centered. But then remember, we removed a little bit of material. So we removed 0.01 inches with our facing operation. So our thickness is not quite an inch. It's 0.99 inches. Okay. And model position, offset from Z, we're just going to go 0. Okay, and that puts it perfectly at the bottom here. Okay, let's go ahead and hit OK. All right, so the only thing left to do really is to remove the rest of the material that's on top of our part. And we can do that with a facing operation. So let's go ahead up, select face. We're going to change our tool, come to our acrylic award tool library. We're going to select our 3-inch face, hit select, make sure our coolant is disabled. A spindle speed of 5,000 is what we want, and a cutting feed rate of 40 sounds good. For our geometry, we're just going to select the bottom now of our part, and we're going to go to our heights tab. Our values are good here. Okay, for our passes, we're going to use a pass extension again of 0.25 and a stock offset of 0.5, so half an inch. And then for multiple depths, we want to do this in 3 passes or 3 layers. So we're going to change that to 0.1. Let's go ahead and hit OK. Okay, that looks pretty good. Let's go ahead and simulate it now. Click on your setup, simulate, make sure your stock is checked and stop on collision. Let's go ahead and run it. And it looks good. We got it in 3 passes. And our third pass should hopefully show the surface of our part, which it does. All right, and that should do it for this particular part. Okay, and when you've checked everything out, you've checked for collisions, and your simulation looks good, double, triple check it, hit okay, and get ready to post-process your code here. So you come up to your setup, right-click, post-process. All right, and for this particular project, we're going to be using exclusively only the Haas. So make sure you select the Haas pre-NGC. Okay, for built-in high feed rate, make sure you select 60 here if it's not already done. Okay, and everything else looks good. Go ahead and post it and save it to a thumb drive, and you're ready to roll. All right, thanks for watching. We'll see you next time.